So the problem is basically this. You have a random variable x. X has a probability density function fx. So you are given this. You know the density function for your random variable x, and you are interested in another random variable y, which is some function of x. The question is, what is the probability density function of y? We're interested in probabilities of y, so we need to know the probability density function of y. All right. So here's the general method, and then we'll do some problems based on this method. So the first thing you should do is, if you're asked to find the density function of y, first figure out what possible values can the random variable y take. So basically this is going to be in 3 steps. To find the density function of y, we will do this in 3 steps. The step 1 is determine values of y. Now step 2, we've done something like this before. I mean, you've seen something like this before when I talked about normal distributions. What we will do is we will first calculate, before we calculate the density function of y, we will calculate the cumulative distribution function of y. And then we take the derivative to get the density function. So write down the cumulative distribution function of your random variable y. So this is basically probability that y is less than or equal to little y. And y is g of x, right? So if you write this as g of x. If it was a one-to-one function, we could just write x is less than or equal to g inverse of y, but it's not one-to-one, so all we can say here is we have to figure out for what values of x will g of x be less than or equal to 1. So this is equal to probability that x lies in some set, which I will denote by ay, where ay is a set of all x values such that g of x equals 1. G of x is less than or equal to 1. And then, how do we find the probability that x lies in some set? Is just the integral over that set of a density function of x. This will make more sense when we actually do a problem. But the idea is you want to find the distribution function of y first. So you can't find the density of function of y directly. You first find the distribution function of y, and then we will differentiate.